Hello, good morning. How was your night? How was your weekend? It's good to have you in the class today. Hope you enjoyed your time over the weekend. Today is the day the government is easing off the lockdown, and I hope that you will take advantage of it. But if not, let's just go down to business. So the past week, you mentioned that some of the calculations I had sent earlier were supposed to be re-explained so that for those that were very difficult for you, we could solve them. And if you check the board, you could have something that I have captioned as illustrations or solutions to illustrations on the concept of an arithmetic progression. This is a type where you are clear about whether an arithmetic progression is actually an arithmetic progression or not. So that's what we have. All right. So for today, let me start with a review of the past things that we've done. So what should you get into your head? What should always be in your head when it comes to arithmetic progression? What is common about APs as usual? So what is common with arithmetic progression? Well, the truth is arithmetic progressions have additions and subtractions in common with them. That is one thing you must get in common. For instance, if you are doing your repeated multiplication where you are adding 2, or probably you are doing your 3 times, so 3 times 1, 3, 3 times 2, 6, 3 times 3, 9, 3 times 4, 12. So when you are doing that, how are you getting 3, 6, 9, 12, 15, 18, 21, 24, 27? How are you getting those things? How are you getting those figures? Was it by cramming all of them? No. The fact is you can actually get those 3, 6, 9, 12, 18, 15, all that. You can get all that by what mathematics calls repeated addition. So another word for multiplication is repeated addition. That's what I want you to get in your head. Arithmetic progression means repeated addition. That's all. But if you want to get the common difference meaning the result of subtracting two numbers, but that the word common is added, means that it is the same all through the sequence that you are given. It is the same all through the sets of numbers you are given. So in 3, if the first term is 3 and the second is 6 and the next is 9, what is the common difference between 3, 6 and 9? It's 3. It's just 3, repeatedly adding 3. So how do I get the common difference? By subtracting 3 from 6, or by subtracting 9 or 6 from 9. That's how I'm getting all of them. So that's just the thing. But so if for instance you get anything aside from that is not a whole number and is not gotten by addition, then you are not getting an arithmetic progression. It might be the other way around. But for today, we want to look at a question that you gave me to solve. And that question says, it says show that the sequence a n under is equal to 3n squared plus 2 they've already told you that it is not an arithmetic. You've already been told that it is not an arithmetic progression. So that's the question. You've already been told that it's not an arithmetic progression. So what are you to do? Now, do you remember what we said about the general formula to use to confirm whether one is an arithmetic progression or not? And we said that this stands for an arithmetic progression where you have, and remember, this here, we're trying to prove whether this is an arithmetic progression. We had done that before using an example where, remember the former example where we said show that the sequence an defined by an equals to 2n plus 3. That one is 2n plus 3 is an arithmetic progression. And we said that for us to do that, first of all, you write out the given sequence. And after writing out the given sequence, replace n by n plus 1. And after doing the whole calculation, then subtract both sides by an. And when you do that, and whatever you get becomes a whole number, then you know that it is an arithmetic progression. So if you follow that process, where first of all you declare the sequence. So let's declare the sequence. So in declaring the sequence, so let me divide this by saying this is a solution. So in declaring the sequence, you say that an is 3n squared plus 2. Right? That is the first thing to do. Did you declare the sequence? Did you follow that pattern and it was difficult for you? So now the next thing for us to do is to replace n by n plus 1. So we need to replace n by n plus 1. So let's see what we'll get. Now look up please. Did you find n in the left hand side of this equation? Did you also find n on the right hand side? So when they say replace n by n plus 1, it's just like when we were solving differential calculus, your differentiation and integration. Remember what we did when we did for first principle, second principle, quotient law, product rule and all that. Remember how we had to do some replacing work around there. So it is just the same thing. All you need to do is to substitute n. Instead of having n as just n, substitute n as n plus 1. So you are going to have that here. Instead of having n, you have n plus 1. And here you have 3 brackets. You put a bracket. Do you know why? You cannot just be having something like this. You can't just be having 3n plus 1 because then you put squared plus 2. No, it doesn't work like that. It doesn't work like that. You have to put a bracket. Now putting a bracket is like placing them in a house. Now I did not put a bracket for here because there's nothing else attached to n. If you are substituting with an unknown and you have a figure, maybe a power, and please you must get this thing into your head. If you are substituting with an unknown in any topic, in any subject, and you have maybe a coefficient attached to the unknown, or you have a power attached to the unknown, as long as that unknown you want to substitute with has something attached to it, you must introduce your bracket. You must introduce your bracket. I hope you are following. Okay, so let's carry on. Now, when we get to this point, all we need to do is to clear the bracket. We need to clear the bracket. Now, in clearing the bracket here, what do we do with this? How do we go about this? How do we go about it? If you have a bracket in this form, if you have a bracket in this form, and you need to get it also into your head, because you might get questions like this where you have a coefficient, maybe 3, and a power 2. Which one goes out first? Which one helps to clear the bracket? Am I going to say 3n, maybe multiply, since a bracket is a multiplication? Am I going to say 3 times n plus 3 by multiplying out and leaving this out? No. The rule says clear with the power first. Okay? Clear with the power first while you keep the others. So what we mean is you still keep your an plus 1 because you have not resolved this bracket. Place this down and increase this. So now we know that this is just one term. N plus 1 is one term. We consider it as just one. What I mean is about considering it as just one is, so what I mean is, okay, over here, introduce this bracket here, then introduce another one, because we are going to have another bracket open for these two. Remember, this shows that this particular thing here shows that you still have 3 by the side. So you have n plus 1 bracket n plus 1. Still close this bracket and put your plus 2. Okay? So what does this tell you when you have two algebraic factors together like this? It means you need to resolve this into a quadratic equation. So multiply these out and let's see what we have. You need to resolve that into a quadratic equation. So for us to do that, I need to clean this side, or instead of doing that, let me clean all this part so that we could have space to work with. So let's resolve this. So n, we need to multiply out here. So we still have our an plus 1 is equal to 3. That huge bracket there. Okay, by the time we multiply out, we are going to have this just one bracket. So n times n is n squared. N times plus 1 is plus n. Plus 1 times n is plus n. Plus 1 times 1 is plus 1. So you have plus 2. So that would be, so imagine this, you have n squared plus 2n plus 1, then plus 2. Okay, so you see it is now into a quadratic equation, not so? Good. So at this point, what do? You can safely use 3 to multiply all of this, right? So we have 3n squared, 3. Once you have a bracket and you have expressions like plus or minus in between, the coefficient, which is the number in front of an unknown, or this 3 here, multiply, this becomes 3 times everything you have here. It becomes 1 term because you have pluses in between. So 3 multiplies n squared, you have 3n squared, plus 3 times 2n, you have 6n, plus 3. Then you can safely add your 2. Okay, so now you are going to have 3n squared plus 6n plus 5. This is 6n, please. So you have 3n squared plus 6n plus 5. So you can bring down this. There's no hard and fast rule about that. You could always do it anytime. Alright, so having gotten to that point, we want to now what do we do? Are we done? Are we done? So you see what an plus 1 has given us. It has given us 3n squared plus 6n plus 5. 3n squared plus 6n plus 5. So now at this point, what do you need to do? According to the formula we have, we need to subtract both sides by an. We need to subtract both sides by an. So that will give us that an plus 1 minus, so the whole of this minus an is equal to 3n squared plus 6n. So you see, because I'm dealing with another unknown, I am going to put a bracket on this 3n squared plus 6n plus 5. Okay, so all we need to do now is to substitute an as the initial thing. The initial value for an was 3n. If you check the question, was 3n plus 2. So anywhere we find 3an, we'll subtract it with 3n plus 2. Right? So that will give us that an plus 1. You have an plus 1 minus an, which will give us 3n squared plus 6n plus 5 minus an, which is this 3n squared plus 2. So if you do that, notice that you have, if we carry like terms, 3n squared subtracts 3n squared, since they are on the same line without an equality sign. So 3n squared minus this is 0. Now 5 plus 2 is 7. Right? Please, what you have there, please, is not 3n plus 2. Is it 3n squared plus 2 that you have? Okay, yes. So this is minus here. This is during your substitution, it's actually a minus sign. It gives you a minus sign. So having done that, this 5 here minus this 2 here, what you are having is, finally, you are having 6n plus 3. So you're having 6n plus 3. Now, remember, we said earlier that once it's not a whole number, look at the final answer we are getting. When we had subtracted an from an plus 1, we are getting 6n plus 3. Is this a whole number? No. Notice that this an plus 1 minus an is not independent of n, because we are getting an algebraic expression but not a whole number. So what that means is that our an plus 1 minus an is not a constant. So let's express that, but first of all, let's have to clean the top here. So since an plus 1 minus an is independent. Let's use independent. That's what I thought about. Is independent of n, then an plus 1 minus an is not a constant. Therefore, the given sequence an equals to 3n squared plus 2 is not an arithmetic progression. So that is it. So because we're having that, it's not an arithmetic progression at all. Okay, so when we discuss general forms, if you remember, when we had to talk about general forms, we mentioned something that struck our attention. We said when we talk about general forms, then we are talking about something that is obtainable everywhere. So notwithstanding where you are in the world, it's the same thing. That's why it's called general form. So you can have a million sequences, right? You could have a million APs, but there's something that always works for them. Let me give you an instance of something you know very well. In the length of an arc, the general form is theta over 360 times 2 pi r. Most times, it's either they don't give you theta, but they give you every other thing. They give you pi, they give you r, and they also give you the perimeter and ask you to find theta. Or they give you perimeter or the length of an arc. They give you theta, which is the angle. They give you pi, but they don't give you the radius. Now, what do you do in that regard? You apply your knowledge of subject of a formula, where, of course, you have several unknowns in a particular general form or in a particular formula, and you need to make sure that you isolate one. So making it a subject of a formula means make it a topic of discussion. Let everybody focus on it. So if I say A is equal to length times width, what is the subject of discussion? What is the subject of the formula? A, which is the area of the rectangle. But if I change that subject and I say that W, which is the width, is equal to A over L, what is the subject of the formula there? It's your W. It's the focus of discussion. It's a focal point. So it's not always straight-jacketed. You could always have a twist in the formula or formulas that you are given. All you need to do is, do you know what to do? Do you know how to solve questions on subject of the formula? Because you are going to use it even in your physics. I'm not teaching you physics, but well, of course, it cuts across everything. So in this regard, they have already given us the number. They say which term of the sequence is 126. They've already given us the number. They've not told us the cardinal point or where it falls. They've not done that. They just said the number is 126. But look at the first term, second, third, fourth, fifth terms. but they've not said this is the term that we're looking at. That's why they say, which term is this? Usually what they will say is, find the 14th term, find the 13th term, find the 100th term. That's what they will do usually. But this is different. They have given you the figure in that term and asked you to find the term. Alright? So let's see what we do. Remember, the general form, which is a normal thing or the usual thing you will do, the first thing you do, please, is to write out the general form. So the general form of an AP is equal to what? If you remember, it's A plus open bracket M minus 1 D. You remember that formula? A plus M minus 1 D. It's a usual thing we used to say when we were in school. Alright, so you have terms or you have expressions you need to get the values of. So you have A is the first term, N is the nth term, and D is your common difference. So the first thing to find, your A, let's write out the parameters. Your A is 6. Let's find out what, so you could choose anything as your common difference. So you could choose to, but first of all, before you even start checking, make sure that the common differences apply for at least the first, second, and third terms that you are given. So you have 11 minus 6 is 5. 16 minus 11 is also 5. 21 minus 16 is also 5. So it continues. Once you get 5, then it means that's the common difference. Okay? So having gotten that as a common difference, this is for the first, second, and the third terms. Having gotten that for the common difference, then what do we need to do? So you declare the 126 that you are given. Let 126 become the nth term. Nth term of the given sequence. Then it is now that AN is 126, right? AN is 126. So that AN actually stands for the arithmetic progression, like the result of the nth term. So the nth term actually is 126, right? Or, so don't be confused, the nth term or you say the value in the nth term. So the value in the nth term is 126. So now we just would need to substitute, right? So please do take down. We're trying to create space for other solutions. So if that is the case, let's substitute. So substituting, we are going to have, so let me use this implies that A plus N minus 1, then D, you have 126. So please let me give you some time so that you copy this down, because we are going to add some things to it. Okay, so I clean, but if you've not finished, all you need to do is to pause and play later when you are done. So according to that, our first term is 6, right? N is what we're looking for, so we'll have D is 5, like we discovered. So you see, we have a bracket, and when you always have a bracket, what do you need to do? You need to clear it, right? So you have that 6 plus 5 is the figure. 5 is the factor of n minus 1. So that becomes, so you use 5 to multiply everything within. So you have 5n minus 5 is equal to 126. So you see it's becoming clearer. So this will give you that 5 plus, or let's make that very fast. So you have 5n is 126. So move all the whole numbers to the other side with their signs changing. So you have 5n is going to give you, so minus 6 plus 5 is going to give us minus 1. So, or instead of that, you could say 126 minus 6 is 120, 120 plus 5, 125. Minus 6 plus 1 is minus 1. Minus 26 minus 1 is still going to give you 125. So if you divide both sides by 5, you're going to have that n is 5 here 1, 5 here 1. 5 into itself is 1. 5 into 12 is 2. 5, remember 2 here. 5 into 25 is 5. So n is actually 25. Hence, so if it's in your WAEC, you must ensure that you state your answers accurately. So the 25th term of the given sequence is 126. Okay, so that's it. So that's what we have. So that explains the two questions. But what I have not seen is you picking out the questions that look similar to this. That's similar questions in your YPass questions and solve them. I'm yet to say that. I'm yet to say that. So please, all you need to do is, now that these two have been explained to you, you need to get back in your past question, find questions on AP and get to solve them. We are yet to finish with AP. We still have some of the first n terms of an AP, and we have some of n terms of an AP. We also have some of the first or the cubes of first in natural numbers. So, but these will still come. But in the meantime, please get done with this, right? If you have any issues, you can also let me know. Okay, so thank you very much. I hope this explains the problems you had at first. I would surely be getting the solutions down, and I hope that in the meantime that you take advantage of this opportunity and work at yourself. So my watchword is practice, practice, practice. Practice does not make you perfect, it makes you get improved. So practice makes for improvement. So try as much as possible to continue practicing until you get better at what you do. So cheers. Thank you.